Hi everyone, welcome to this class. We'll be talking about servo motors. What are servo motors? Servo motors are simply electronic components which moves at an angle of 180 degrees, but you can actually regulate the amount of degrees it moves at a particular point in time. So let's jump right into the course so you can understand exactly what you're going to do. So we click on Start New Circuit. So on the dashboard, click on Start New Circuit. Opens up a new workspace for us to start working on our new project. So normally we have to go down, dragging our Arduino Uno Rev3 into the wiring workspace, and right now we're not going to use the breadboard small, so we are just going to connect our component directly from the servo motor to the Arduino Uno. Now we have to search for servo motor. So if you scroll down a bit, you see something down there called a micro servo. So there are different servo motors. There's a hobby gear motor. Well, that's not really a servo motor, but it's a motor. So there's a hobby gear motor. There's a DC motor. There's some other motors you can actually work with. But for this class, you'll be working with servo motor. So you drag your servo motor into your workspace. So this is your servo motor 90G plastic gears. So you might not know that because this is just a simulation, but that's the specifications. So your servo motors has three pinouts. The first one being the ground, second the power, and then the last one being the signal. So that signal, that means that's the power, the data pin. So don't be so confused. So if you come over to this dialog box here, you can select the type of servo motor you want. There's positional and continuous, so we'll be using positional. For continuous, your servo motor just keep moving continuously around an axis. But for positional, you can select what points you want your servo motor to move at a particular instance. So the first one, which is the ground, we click inside the ground pin and then drag out our wire. Then connect that ground pin to GND on the Arduino board. Change that color of the wire to black because we're going to be making use of black color for our negative pin. So the middle one is the power rail, and a servo motor uses 5 volts power pin or 3.3 volts, but we're going to be making use of 5 volts. So we connect that to 5 volts power. So 5 volt power is just at the other side of your Arduino board. So you connect that to 5V. So 5V is your 5 volts. The 5V is just the short form of it. So that wire is going to be a red wire, which is for power. So just strictly for power, to power servo motor. So lastly, the last one is the signal. So this is for data. So this is the wire that makes you transfer data from the Arduino to the servo motor to tell it what position you want to place your servo motor. So you click inside your signal or the data wire and then drag out your wire, then connect it to a digital pin, most likely a PWM pin. So connect it to pin 10 because it is a PWM pin because of the little tilde at the front of it. Now we're changing this color of the wire to orange, which signifies data. Orange. We're done with the wiring for our project. It's now time for us to move into the programming aspect. So we're writing our instructions on C++. For the first one, we will inside the void setup. We will not write anything inside the void setup and void loop yet. We have to use something called a library. What is a library? A library is a directory which stores in a set of codes or set of instructions which you can just call in your program whenever you need it. So you can put in a library into your program, and then you can call whatever function it that's already pre-built inside the library. You can just call that into your program and it's going to work smoothly. So you can create your own library by writing all the sets of instructions. You save it in a file and then you can import it into your Arduino. At the top corner of a project or the workspace, you will discover there's this option which is download. You can download the code you've worked with, and beside the download you will see libraries. So these are where all the libraries have been stored. Tinkercad has a limited amount of libraries that it has online, and it doesn't give room for you to add any other additional libraries. So we'll be making use of the Tinkercad libraries. So click inside the libraries, you will discover there are some libraries that are here. There's like a remote library, liquid crystal display library, um, keypad library, wired library, stepper motor library. So there are some libraries here, but for now we'll be working with the Servo library. So to include this library and whatever code that's inside the library, you just click on this include option beside it. So here you will discover that this code automatically writes at the top of your program hash include servomotor.h into um, a greater and a less than symbol. Okay. So inside so after your library has been declared with the file name there, you you can now type in an instance which is servo space servo underscore 10. So this code just simply says from this servo objects which has been created inside the library, I want you to create an instance. That's I want you to create a child from this parent servo. So name that child servo 10. So that's just simply what I just did here. So from this parent option here, from this parent code here, servo, please create this child code which is servo 10. So to create a new instance from servo. Now we go into the void setup. So what we simply do here, we will give our program place where the pin is connected. So we just type in this function servo underscore 10, which is that instance we created. We call in a function called attach. So attach is a function that takes in three parameters, but you can optionally put one parameter inside. So here we specify the number of pin, the pin number we are using on the Arduino. So we're using pin 10. So we type in pin 10, close the brackets, and then close the statement semicolon. So I told you that it takes in three parameters, which is the pin number, the time, and the speed at which the servo motor works. So, but for now, we'll just be using the pin number. That's for inside the setup code. So now inside the loop, we now specify what angle we want our servo motor to move at a particular point in time. So we just type in this syntax servo underscore 10 dot write. This is a function from our library. So you must just have the library for it to work properly. Okay, so function dot write. So this will now give the particular direction you want our servo motor to move to. So in here, I'm going to write 120 degrees. So it works in degrees. So I'm going to put 120 degrees. And I will add a delay. So I'll call my delay function and then type in 500 milliseconds. Next, I will call my servo instance servo underscore 10 dot write. So open and close my brackets and close statement to semicolon. So next, I'll type in the next angle or the next coordinates, which is 70 degrees. So put in 70 degrees, then add a delay, add my delay function and close it to the semicolon. So inside the delay function, I'm going to add 500 millisecond. So for the next coordinates, type in servo underscore 10. You can just simply copy and paste, but typing it makes you remember it faster. So inside my right function, then I write the other coordinates 180 degrees, add the delay, for 500 milliseconds, that's like 0.5 seconds. Then lastly, add my last coordinates, which should be servo underscore 10 dot right open bracket, close bracket, and then put in what angle. So I'm going to put 360. So now lastly, now I put in a delay. So this should be for 500 milliseconds. So that's all for the code. So to make sure it works properly, you have to test run it by running our code. So you click on start simulation. Well, we're done with the coding aspect of our project. So if you click on start simulation, you discover that there's an error in between your code. So this error is actually intentional. This is a syntax error, which is actually intentional for you to understand how little errors in codes like this will make your program not to run at all and your projects will be run faulty. So let's just correct or debug our error. So if you come over to this dialog box, just as shown before, you see the line in which the error happened. It happened between line 9 to line 12. So it's saying the error expected semicolon before the attach. So it's saying in between servo 10 and attach, there must be a semicolon or a particular symbol that will differentiate in between these two syntax. So here we just put a full stop to tell our program that this is a continuation. This is a full statement. So this is a full function statement. Yes. The reason why we put the full stop there is that the attach is just an extension of our servo 10 instance. Okay, so we say inside servo 10, then we now call a method. So the servo 10 is just an instance from an object, like I explained earlier. Servo 10 is instance from the object servo. So the servo is like the parent, and then the servo 10 is the instance, is the child of that parent. So now when you put a full stop on after any of your instance or objects, it means you are calling the methods or the function that is inside the parent. Okay, so whatever function that is inside the parent can be also be used for the child. So dot attach is a function or a method that now attaches that particular pin number to servo 10. Same thing goes with servo 10 dot write. So dot write is a method or a function that actually writes that particular amount of direction to servo 10. So you have to call in write for it to know that okay, this is actually for the child servo 10. With that being said, just debug, put a full stop in between servo 10 and attach. Then you click on start simulation again, and now you see our project is working properly. All right, so if you follow through and you saw all the errors and how to debug errors and also how to work with servo motors, we've come to the end of this class. Now, next class, we'll be working with basic analog sensors. So stay tuned.
Ciao.